Great, let's go ahead and move on to chapter 2.2. Go ahead and take a minute to take a picture of these notes if needed. Make sure to refer back to them. I'm going to go over them pretty briefly. But here's my graph of a parabola. This line here is what we call the axis of symmetry. We notice that it cuts through the vertex at h comma k, right? And at x equals h describes this line. It's kind of like the equation for it, right? At 0 comma c, which we'll talk about where c comes from in just a minute, that is the y-intercept. We're also going to talk about p and q, or some like to call it p and r, depending on where you're at. But those are our x-intercepts, okay? The vertex also describes if it has a maximum or a minimum, right? So a maximum point would be if it was frowning, frowny face, and a minimum is where it's smiling. Okay? All right, to find the axis of symmetry, sometimes we will use this expression here, this formula, right? And we use standard form to help us out here. So we need an ax squared plus bx plus c. This b here goes right up in here, and our a goes right there. And that gives us this line here. You'll also notice that h, right, from our vertex is the same thing that goes through that point, that x value, right? So that's going to be our negative b over 2a if you ever need to find h and you're not in the right form. So negative b over 2a. When you plug negative b over 2a in to the function, so that all that is that you have f, you've plugged negative b over 2a, which is h, right, into the function, you will get k, which is that y value. That will be for your vertex either the minimum value or the maximum value, depending on what we're looking for. Okay? Intercept form describes where the x-intercepts are, so it really should be called x-intercept form. We're left with a, so remember a is our vertical stretch, shrink, and reflections. We're left with p and q, and when we set these two factors, so this is a factor and this is a factor, when we set those two factors equal to 0, we can solve for x. So we'll get an x equals, and that will tell us where our x-intercept will be. So something like this. Right? All right. Let's talk about increasing, decreasing, and domain and range. So if a function is like looking like our parabola here, right, our domain is going to be all real numbers. And I like to write that as negative infinity to positive infinity using interval notation. No matter what parabola it's going to be, the domain will always be negative infinity to positive infinity. Okay? Again, to find the minimum or maximum value, you're going to go ahead and solve for the vertex. Okay, there's plenty of ways to do that. But the value, when it asks for a specific value, you're going to give the k version. So you're not going to give h comma k. You're just going to say for the value that it is k. Okay. The range are all the possible y values. So if I'm looking at this graph here, I have nothing that I can choose under here until I get to about here, because our first point on the graph is here. And we're talking range is vertical, right? So from here onward, I can choose any point on the graph, right? And it goes all the way on to infinity. So it starts at your k to infinity. If it's frowning, right, so if our a is negative, so we have like negative a x minus h squared plus k, blah, 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 right? That's going to be like this. And that's going to have a maximum value instead. So same rules apply. It's going to be your k. Domain is the same. What does change, though, is our range. So if we look at this point here, this is our k. We can have anything on the bottom of this function, y value-wise, right? But once I get past this k value right here, I can't choose anything up there. So we're going to go from negative infinity to k. So negative infinity to k. You'll notice that I include a closed bracket when I want to include the number. I use an open bracket when I'm talking about numbers like infinity, or if I'm talking about increasing and decreasing intervals. Let's talk about increasing and decreasing. So for a function like this, we are decreasing from, and we read this on our x-axis, from negative infinity to whatever our h value is. And we're going to keep them as open brackets. Okay? Then our increasing is going to be from our h value to positive infinity for a function like this. So remember, this is when a is greater than 0. You don't need to graph this to see this. Same thing with this one, except for a is less than 0. We are increasing from negative infinity to 0, or sorry, negative infinity to our h value. And then we are decreasing, right, going down from h, oops, sorry, we're going to include h, no, not include, h, comma, positive infinity. Do not include h for the increasing and decreasing. That's my fault. Remember that the domain are all the possible x values, where the range is all the possible y. And now we're going to go over the properties of graphs. So we have a function that's written in this form, right? These are our two factors that we set equal to 0 to go ahead and find these points here, our x-intercepts. Let's say you wanted to find the vertex, but you don't want to go ahead and you don't want to FOIL this out and make sure you're simplifying it properly, and sometimes we don't have time for that. So to find the axis of symmetry, we look for the point between the first intercept and the second intercept, and we divide that by 2, and that should remind you of the average, right? Or the mean. So you're going to have p plus q divided by 2, and that will be equal to your h value. To get to your k value, if you need, remember, just plug that back in and it'll spit out k. Okay? Awesome. Let's go ahead and get started with these. So, remember, if anything looks off or weird, please let me know. I am not perfect, and I am going pretty fast through this material today. So, if something's not quite right, leave a comment, send me an email, do what you need to do, and we'll fix it, okay? So the first thing we need to do is label the vertex and the axis of symmetry. Okay? Then we're going to find the maximum or minimum. Then we're going to find the domain and range and increasing and decreasing intervals. Awesome. So this one is in our original form that we've learned, which is the vertex form. X, I'm going to use minus h squared plus k. And you'll notice that our vertex then, our h comma k, is going to be negative 1 comma 0, because this doesn't have anything attached to it. So we're going to put plus 0. Okay. Then we're going to plot that. So I'm going to go negative 1, 0, put a point here. Okay. And then we also need to label our axis of symmetry. So I know that I'm going to have a dashed line right here for my AOS, which is x equals my h, which is negative 1. Okay, so we have negative 1 comma 0 is the vertex. Okay. Then we're going to find the minimum or the maximum value of the function. So because a is greater than 1, right, we have a minimum. Okay? Then we need to go ahead and describe increasing and decreasing. So I'm just going to sketch this curve. I'm not going to be too strict with it because I want to only focus on finding the, let's see if it'll let me move this. I only want to focus on finding the vertex right now. Okay. So the domain is going to be all real numbers, so negative infinity to positive infinity. My range is going to be from 0 to positive infinity, and that's because we start at 0 and we can keep going forever. The next thing that we're going to find is the increasing. Okay, so I'm increasing from negative 1, and then forever on after that in a positive direction, right, because it's going towards positive infinity. So that's going to be -1, positive infinity. And then I'm decreasing from negative infinity to -1. Decreasing from negative infinity to -1. Awesome, let's keep going. So for this one, right, my a right up here is less than 0. So a is less than 0, so we will have a maximum. Next, I'm going to go ahead and write down my h. So h equals 4, k equals -5. Okay? And that is going to be our vertex. So 4, -5. Remember, we choose the opposite of whatever the sign is. Okay? It's not a very good explanation, but for right now, that's what we're going to go with. Okay? The next thing we need to do is describe the axis of symmetry. So I'm going to go ahead and draw my lines first. And so I know that I'm going to have an h at 1, 2, 3, 4. I'm going to go by 2's for this one. So 2, 4. So here's my axis of symmetry at h equals 4. So AOS is x equals 4. Then we have our vertex at 4, -5. So 2, 4, -5. And again, we're going to try to only focus on the vertex. Oops, I drew that wrong. We have a maximum, right? So that's not going to face upwards, that's going to face downwards. Actually, I'm going to make that a little nicer. Some of these are getting a little big. There we go. Awesome. Okay, so we have our domain. Remember, it's all real numbers, so negative infinity to positive infinity. My range, I can choose anything on the bottom here, all the way until I get up to -5. So we're going to go from negative infinity to -5. We're going to have our increasing, right? And we look at that on the x-axis, but we look like we're increasing from here to here, right? Because we're going up. So that's going to be negative infinity to our h value, which is 4. And then for decreasing, right, we're going to go from 4 to positive infinity, because that is going from 4 onwards down forever towards the right. Great, let's talk about this next one. This next one is not in the form that we want it to be in, right? However, we do have an a and we do have a b, so I can say x equals -b over 2a to get our x for our axis of symmetry. And that is going to be equal to, I have a -3 and then a 3 over 2. So this is going to be -3 over 2, and my a is 3 over 2. So negative times a negative is a positive, and then 2 times 3 is 6, divided by 2 is 3. You can also think of it as 2 divided by 2 is 1, and 3 divided by 1 is 3. So this will be equal to 1. Okay. Now we're going to go ahead and plug that back in to get our k. So t of 1 equals 3 over 2 times 1 squared minus 3 times 1 minus 1. This is going to be 3 over 2 minus 3 minus 1. This will be 3 over 2 minus 6 over 2 minus 2 over 2, which will end up being 3 minus 6 minus 2 over 2. Okay, 3 minus 6 is -3 minus 2 over 2, which will give us -5 over 2. So let me go ahead and see if I can't find my calculator. I just dropped it again. I'm going to go ahead and check Desmos on this one, because sometimes things just get a little wonky in the brain. So let's go ahead and open up Desmos here. Yep, that looks just about right. Awesome. So this is not about, it actually is negative 2.5. So we're going to go down 2.5. There we go. And this, our A value, is greater than 0, so it is going to be a happy face. So it's going to look something like, oops, not like that. Something like that. So our axis of symmetry here, this is going to be AOS, which was x equals 1. And then our vertex was 1, negative 2.5. Okay. We have a minimum here. Okay. I should probably write minimum. Let's talk about domain and range. So my domain, shocker, is going to be all real numbers. My range, right? Remember, this starts from going from bottom to top, starts at negative 1 and will go on towards infinity. My increasing goes from 1 to positive infinity, because this is where we're trending upward, right? That's where my slope is going. So we're going to have 1, infinity, and that means that my decreasing has to be on the other side at negative infinity to 1. Awesome. All right, let's take a look at the bottom part here. So we need to find the x-intercept, the vertex, and the axis of symmetry. So first things first is we're going to set these factors equal to 0. So we're going to have x plus 4 equals 0, and we're going to have x minus 3 equals 0. That's going to leave us with x minus 4 equals x minus 4, and x equals 3. Okay? That means that I have an intercept at negative 4, 0, and 3, 0. So I'm going to go ahead and plot those. So 1, 2, 3, 1, 2, 3, 4. Let's go ahead and find our vertex now. So vertex, right, our h is equal to negative 4 plus 3 over 2, right? So negative 4 plus 3 is negative 1, so negative 1/2, or 0.5, okay? And we're going to plug that back in. So we're going to have 4 times negative 1/2 plus 4 times x minus, times negative 1/2 minus 3. We're going to make sure they have common denominators. So we have 4 negative 1/2 plus 8 over 2, negative 1/2 minus 6 over 2. That's 4 times negative 1 plus 8 is negative 7 over 2. Negative 1 minus 6 is negative 7 over 2. Okay. 7 times 7 is 49 over 4 times 4. Those cancel, and we get 49. So that's way, 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 way in like another dimension. And we should have gotten, my bad, this should have been a positive here. There we go, problem solved. So that's way down here somewhere. Okay. So I'm just going to do this. Call it a day. Okay. So that means that my vertex is at negative 1/2, negative 49. Okay? My axis of symmetry is going to be over here at negative 1/2. So this is my AOS at x equals -1/2. Okay, let's go ahead and move on to this one. So this is definitely a factor, but a lot of students ask if this is a factor, and the answer is yes. It's got an x mingled up in there, so we're going to count it as a factor. So that's going to be -7x equals 0, and that is x minus 6 equals 0. So don't be worried about this one. We're only going to be dividing the -7. That means we get x equals 0, and that means that we have a vertex at 0, 0. And then here, we're going to add it to the other side, so we have 6, so this leaves us a x-intercept at 6, 0. I might have said vertex for this one. That one is an x-intercept, not a vertex. Could be, actually. We haven't figured that one out yet. To find the h value of my vertex, that is going to be 0 plus 6 over 2, which is 6 over 2, which is 3. So that means that my k, right, if I plug that back in, that's 7 times 3. -7 times 3, and then 3 minus 6. So this will be -21 times -3, which should be 63. I'm going to go ahead and double check that one because that seems a little strange to be getting such a strange number once again. Let's see. Oh, yep, not crazy. Cool. So my vertex is at 3, 63. I'm not graphing that. I don't have time to graph that. So what we're going to do is we're going to graph the x-intercepts first. So we have 0, 0. We have 1, 2, 3, 4, 5, 6. I'm going to go by 2. So 2, 4, 6. And I'm going to be very conservative with how narrow this is. Okay? Because my vertex is somewhere up here. Okay? So 2, 3. Here's x equals 3 for my axis of symmetry. For my AOS. And then we're just gonna let the imagination run for where that vertex is because I don't want to graph that or deal with the scale today. I know that this is going to face upside down because, again, this is negative, so this is going to be a frowny face. Okay. All right, let's talk about this one. So we have 2 questions here. So let's answer the first question. So here is the first question in green. Let's see, what was the highest point it will reach? So let's read this out. A softball player hits a ball whose path is modeled by this crazy thing, where x is the distance from the home plate in feet and y is the height above the ground in feet. What is the highest point the ball will reach? That is asking for the vertex. And I'm going to have you guys find that on your own. It is in the Desmos link that I provided. And then it wants to know, for the second part of our question, get a new color here. It wants to know that if the ball were to hit center field, which is an 8-foot fence located 110 or 410 feet from the plate, was this hit a home run? So I need you to look at where the ball hits the ground on the graph, right? Should look something like this. So this is where it hits the ground. And I want you to tell me, does it pass the 400 feet mark and does it pass the 8-foot mark? So will it make it over the fence and will it make it across the 410-foot barrier? All right, so we're going to go ahead and go through 2.4 for our last section of the day. Go ahead and take some notes if you need. I've even added some extra notes down here about the different types of linear equations, and then the solutions that they might have if you have 3 of them. So you have one solution where they all intersect, you have infinitely many solutions, or you have no solutions because they're parallel lines. Okay? Rate of change, average rate of change. I always tell my calculus friends this, that average rate of change means slope. A is for algebra, right? And so this might look a little funny, but remember that when we plug something in, we're pretty much getting the y coordinate. So this would be y2 minus y1 over x2 minus x1. We've just written it with function form instead. So remember that f of b gives us the y coordinate and b is the x. A system of 3 linear equations is when it has the form like this, where A, B, and C cannot be 0. Many of us will be only working with 2 systems, so you might see some 2 systems in your homework. And just like our linear functions from chapter 1, it gives us a little bit of concept here on what we need to do with writing equations. So if we are given a point and a vertex, then we're going to use this form. If we're given a point and the x-intercepts, then we're going to use this form, because it's vertex form. It's got the vertex in it. It's got the intercept form because it's got the intercept in it. And if we're given 3 points, like x, y, and z, then we're going to write and solve a system of 3 equations. All right, let's go ahead and get started. So I'm given a vertex and a point. So the first thing that I'm going to do is I'm going to go ahead and write out the form that I need to be using. So I need to be using y equals, and let me make sure it wants me to use y. Yes, awesome. So we're going to use y equals a x minus h squared plus k, okay? And the first thing that we're going to go ahead and plug in is our h and our k. So this is y equals a x minus 2, because this is this part here, squared plus negative 2. Okay. Then we're going to go ahead and simplify. We have y equals a x minus 2 squared minus 2. We're going to plug in another set of points. So we're going to plug in this set now. So this is going to be 6 equals a, and then we're going to plug in 4 minus 2 squared minus 2. This is because we want to be left with only one variable, and that variable is a. So this is going to be 6 equals a, 2 squared minus 2. 6 equals 4a minus 2. 8 equals 4a, and a is equal to 2. So then we're going to plug that a back into the equation here. That's going to be y equals 2x minus 2 squared minus 2. Lovely. Let's do the same here. So I'm going to write out my form, because I have a point, and I have my point here, and then I have my vertex. So this is going to be y equals a x minus h squared plus k. This is going to be y equals a x minus, I'm going to plug in 0, squared plus my k, which is 3. I'm now going to go ahead and plug in my x and my y's. So I have 1 equals a times 2 minus 0 squared plus 3. And now I'm going to simplify. So I have 1 equals a, 2 squared plus 3. 1 equals 4a plus 4. Okay. I'm going to go ahead and subtract. Oh wait, did I plug in a different point here? I should be okay. Hold on, let me just make sure I'm plugging in the right points before I go any further. Yep, I guess it works. Just seems weird to me. Oh, that's why it's weird. I've completely made up an extra point. There we go, that's supposed to be a 3. That's crazy. I'm going to go ahead and subtract, so I get a 2 equals 4a, negative 2. Okay. And then I'm going to get a equals negative 1/2 when I simplify. There we go. Now things are coming back together. I'm going to plug this in. We're going to have y equals negative 1/2 x plus or minus 0. You don't have to write the minus 0. You can just write x squared. But I'm going to leave that there for now. Plus 3. Okay. Same thing, we have a point and we have a vertex, so we're going to do the same thing. We're going to have y equals a x minus h squared plus k. Same thing for this one. I'm just going to write this down before we get to that problem. There we go. So my vertex is -1, 8. So I have y equals a x squared. And then I'm going to plug these in. So I'm going to have -1. And then I'm going to have -8. Trying to fill this in. Sorry. There we go. And I'm going to simplify it out a little bit. So I have a x plus 1 squared minus 8. Then I'm going to plug in my point that I have. So we have 0 equals a x, and then we have plus 1. Oh, let me plug in my x. This would be -3 plus 1 squared minus 8. This is 0 equals a, and then we have -3 plus 1 is -2 squared minus 8, which is 8 equals 4a. Did 2 steps in one. See if you can try that one out. All I did was I went ahead and added the 8 and then simplified this here into a 4. Okay. Oops. Hold on, I mixed up my notes here. Should be okay. Should be good. All right. Sorry about that. So then we're here. So we have our a, and we have a is equal to 2. Okay. So I'm going to write this as y equals 2x, go back to here to plus 1 squared minus 8. And that is my expression. Let me recolor this. Not expression, sorry, that is my quadratic. Oops. Same thing here. So we have the point that it passes through. I'm not going to color code this one this time, but this one is going to be y equals a times my vertex, which is -2, so x minus -2 squared plus 5. And so it's going to be y equals a x plus 2 squared plus 5. Then I'm going to plug in my point. So I have 7 equals a -4 plus 2 squared plus 5. Subtract the 5 and I get 2 equals a -4 plus 2 squared. -4 plus 2 is -2. So I have a -2 squared, which is going to give me 2 equals 4a. That means that a is equal to 1/2. Okay. So this one, when I plug this back in to my vertex form, we're going to have y equals 1/2 x plus 2 squared plus 5. Okay. Now we're going to be working with intercept form. One, I know that it says intercept form here, so I know that's what I'm going to be working with. 2, I noticed that it gives me the intercepts as well. So my brain goes, oh, I should be using intercepts here. Okay, so let's go over this next part. So I'm going to write out my expression first. We're going to have y equals a x minus p, and then x minus q. Okay. We're going to plug our points in. So we're going to have y equals a times x minus -4 times x minus 6. And that's going to be y equals a x plus 4 x minus 6. That comes from here and here. Then I'm going to plug in my extra point here. So that's going to give us 25 equals a times 1 plus 4 and 1, because I have 2 x's there, minus 6. So it's 25 equals a times 5 times -5, which is 25 equals negative 25a. So a is equal to negative 1. And then we can rewrite this as y equals negative 1 times x plus 4, x minus 6. Okay. Same thing here, but I'm going to change these points right here. I don't like looking at those very much. So let me go ahead and change these to negative 7 over 2, negative 1/4. Negative 7 over 2, I found that by multiplying and then adding. Okay, so 3 times 2, negative 3 is negative 6 minus 1 is 1, or if you wanted to add, it'd be 3 times 2 plus 1. And then you just multiply the negative at the end. So remember that we have y equals a, x minus p, x minus q. So we have y equals a, x minus negative 4 times x minus negative 3. Okay, so this is going to be a, or y equals a, x plus 4, x plus 3. Okay, we're going to plug our points in. So I'm going to plug this point in here, so negative 1/4 is equal to a times negative 7 over 2 plus 4, negative 7 over 2 plus 3. Remember, fractions need the same denominator in order to add, so negative 7 over 2 plus 8 over 2, negative 7 over 2 plus 6 over 2, negative 1, oops, put the 4 in the wrong place, negative 1/4 equals a, and then negative 7 plus 8 is 1/2, and then negative 7 plus 6 is going to be negative 1 over 2. So that's negative 1/4 equals a. 1 times negative 1 is negative 1. 2 times 2 is 4. Negative 1/4 divided by 1/4, or negative 1/4 divided by negative 1/4 is going to be negative, or is positive 1. Right, because a negative divided by a negative is a positive. So then we're ready to fill that one back in. So this one should be y equals 1, and you don't have to write the 1, but this will be x plus 4 and x plus 3. Awesome. 2 more to go. This one gives me the x-intercepts, and it also goes ahead and gives me the point that it passes through. So I'm just going to fill these expressions in with all the points now. So we start with an 84 because we have y equals a, x minus p, x minus q. So I'm going to have 84 equals a, my x is 1, my p is negative 5, my x is 1, my q is 8. Okay, so this will be 84 equals a times 1 plus 5 times 1 minus 8. So 84. This will be 6, and then 1 minus 8 is negative 7. So that will become negative 42 is equal to, no, negative 42a is equal to 84. So then 84 divided by 42, or negative 42, is negative 2 equals a. Okay, so then we can just finish setting this up. This will be y equals negative 2x. This goes back over here to right here and here with these and these. This will be x plus 5, x minus 8. Okay. Last but not least is this question here, similar reasoning. I'm going to break this one down again, just like I did the last one. We have y equals a, x minus p, x minus q. My y value is 27. We don't know a. We have an x value of -2 and a p-value of 7. We have an x value of -2 and a p-value of 10. Okay, so this will be 27 equals a times -2 minus 7 is -9. -2 minus 10 is -12. So 9 times 12 is 108. Right? Oops, let me write it like this. We have 27 equals 108a, right? And then 27 over 108, right? That should be a fourth. So that would be a equals 1/4. Then we're going to fill it in. We have y equals 1/4 x minus 7, x minus 10, because that's how we plug it into our formula there. It's minus 10. And that's it, my friends. So we should be able to do this with vertex form, standard form, and intercept form. We should be able to make the graph given the function, or we should be able to create a function based off of a graph. If you have any questions for the upcoming exam, my office hours for the 24-25 year is 9 a.m. to 12. So email's open. And remember, if it's urgent, go ahead and mark it as urgent. One more thing before you go. We're going to go over this part in class together the next time we meet. See you guys soon.